Hi, today we're going to look at angle bisectors. So we've already talked about segment bisectors, and we know that's anything that divides a segment equally into two halves. So before we do that, I do want to review a little bit of what we talked about yesterday, which was the angle addition postulate, which was similar to the segment addition postulate, where you can add two segments together to get a whole segment. Yesterday we talked about adding two angles together to get a whole angle. So when I look at this and it says, if angle RDE and angle EDA are adjacent angles, even before I go on, as soon as I read that I've got adjacent angles and I don't have a picture, I'm going to sketch that. Angle RDE, so RDE, I know D is the vertex, and it's the vertex for both of them. RDE, I don't know how big it is, I just kind of guessed. Okay, and then EDA are adjacent angles. So the point they have in common are E and D. E and D is in both of them. DE, DE. So I know DE is what's shared. So EDA, EDA. And I don't know if I don't know what size they look like. This might really be obtuse. This might be really tiny. I don't know yet until I do the problem. But I do have my picture drawn, my two adjacent angles. Then let's see, RDE, so that's the blue angle that I drew, is 5x plus 20. EDA, that's the orange angle that I drew, is 7x plus 4. And it tells me that RDA, so let's see, I didn't finish labeling my orange. EDA, I've got my E, I've got my D, I need my A. There we go. All right, so RDA is 120 degrees, it says way over here. R to D to A, so that's this whole thing, is 120 degrees. Okay, so my angle addition postulate says if I add these two adjacent angles together, I'm going to get the whole thing. And normally I write that out, but for time's sake today I'm going to just kind of shorthand it. So I'm going to say my blue angle, 5x plus 20, plus the orange angle, 7x plus 4, is going to give me a sum of the whole green angle, which is 120 degrees. Okay, so let's go ahead and see what we need to do to solve this. First thing I can see is I need to combine my x's together. So 5x plus 7x is 12x. And then I'm going to combine my constant numbers together, my 20 and my 4, and get 24. Equals 120. Next thing, subtraction property of equality. So 12x equals 120 minus 24 is 96. Then I'm going to use my division property of equality. 12 over 12 is 1. 1x equals 96 divided by 12 is 8. So find the measure of each angle. So I haven't done that. All I did was find x. I need to find the measure of each angle, which means I need to put an 8 in for this x, and I need to put an 8 in for this x. So that way I can find each angle. So when I look at the first one, my blue angle is going to be 5 times 8 plus 20. So 5 times 8, that is 40, plus 20, so that is 60 degrees. So this angle is 60 degrees. Okay, let's find my orange angle. My orange angle, EDA, is going to be 7 times 8 plus 4. So 7 times 8 plus 4. 7 times 8 is 56, plus 4 is 60. So this angle is 60 degrees. And then we can check that because those two angles together should make the whole green angle, which is 120 degrees. So does 60 plus 60 make 120? Yes, it does. So I did all of my math correct. Okay? Look at the question I have on the next one. It says, look at your answers in the problem above. What do you notice about the measures of the two adjacent angles? So my two adjacent angles were 60 and 60. They're both exactly the same. They have the same measure. So that means we can say they are congruent. Okay, if you don't remember the symbol for congruent, it looks just like equals, except it has a little squiggle above it. Okay, they have the same measure. They are congruent. The two angles are congruent. Okay, that brings me to our first definition today, and that is an angle bisector. And it's just like a segment bisector, except it's dividing an angle. An angle bisector is a ray, and it could also be a line, but it's a ray or segment or line, two-dimensional figure, that divides an angle into two congruent angles. Okay, so in my example above, I can say that angle R, or that ray DE, so look where ray DE is. That means it starts at D and it goes in the direction of E. So this ray right here, we can say that it is an angle bisector in angle RDA. RDA, the whole angle, this is bisecting it. So it is an angle bisector. And just like we use tick marks to show that segments are congruent, congruent angles are marked with matching arc marks. So in this picture, I can add an arc here, and then I put the same arc here, and those single arcs mean in a picture that those angles are congruent, and I'm allowed to add them only because I have proven those angles are congruent, so I can add the arc marks. If a picture comes with them, then you know that they're congruent. Otherwise, you have to mathematically be able to show they're congruent. Okay? So in the next video, we're going to look at what to do if you're already told you have an angle bisector. Okay? Thank you so much for watching. See you on the next video.